Hi, I'm Herb Gross, and I'd like to welcome you to what I hope is going to be a very, very exciting and informative voyage into the world of algebra. I'm hoping that some of you are already old-timers in this style of instruction, and that you've completed Gateways to Mathematics, our prerequisite arithmetic course, and I'm assuming that some of you are newcomers coming on board, having already learned your arithmetic and starting off in the field of algebra. A long time ago, I learned a slogan that said, you only have one chance to make a first impression. So rather than get into subject matter in this opening session, I'd like to take the time to have me get to know you and possibly for you to get to know me. I don't know exactly what the various reasons are that everybody will be taking this course, but the one thing we will assume is that since on Star Trek alone, time is refundable and reversible in every place it isn't, I'm assuming that anybody who's taking this course wants to at least make sure that for the time they're putting into it, they're getting something out of it that's worthwhile. And it's my job to make sure that that happens. It's my job to make this course as pleasant for you, as meaningful for you, and to bring up something which I'll probably mention more than once during this course about something I learned from one of my sons who was an excellent football player. And he went to double sessions every August for 8 years, meaning before football season began, they would practice twice a day in August in this blistering heat, but whenever I asked him to mow the lawn, it was always too hot. And it took me a long time to understand this, that he was really telling the truth, that it was too hot to mow the lawn, but it wasn't too hot to play football. And the reason that it wasn't too hot to play football was he enjoyed playing football. He didn't enjoy mowing the lawn. And the lesson I learned from that is that the only difference between work and play is not the degree of difficulty, but the degree of enjoyment. If you're enjoying something, you won't mind if you're working hard. And if you feel that you're growing from something, you won't mind paying the price for that. And so it's my job to give you the feeling that you're going to grow and going to learn. Now, one of the first reasons that people have trouble with mathematics has nothing to do with their mathematical ability. The real reason that many people have trouble with mathematics is that mathematics is a language unto its own. And what happens in the language is there is a difference between the word and what that word means. I mean, I have a favorite riddle I love to give people. It's not that exciting, but you might enjoy it. And we'll take a minute to let you look at this thing. It says, make one word out of new door. Make one word out of new door. Okay? Rearrange the letters in new door to make one word. Well, maybe some of you have figured it out already, and those of you who haven't figured it out will get angry with me if I take much more time to show you, because the answer is not what you think it's going to be. Let's take a look and see what the answer is. The answer is one word. See the N, the E, the W, the D, an O, and an R. Rather interesting thing. One word is actually two words. You see the difference? The concept of one word takes two words to express. Let me see if I can give you a deeper example of that. Let's suppose that there's a black cat in the corner of a room here. And I'm going to give you two true-false questions. The first true-false question is, true or false, the cat is black. The second true-false question is, true or false, el gato es negro. Now, you're going to be honest with me, okay? So for this first question, I say to you, true or false, the cat is black. You put down true. Now I say to you, true or false, el gato es negro. Well, this happens to be Spanish for the cat is black. Suppose you don't know any Spanish. You can't say true. By the way, you can't say false either, because to call something false means you first have to understand it. If you don't understand it, it's neither true nor false. The only answer you can give over here is I don't know. Now, is there another reason why you might have said I don't know? See, one reason would be you didn't understand Spanish, okay? Why else might you say I don't know? Well, you could have been colorblind. Maybe you couldn't recognize that the cat was black. See, suppose you understood Spanish, but you couldn't tell the color of the cat. What would you say then? I don't know. We say it in Spanish, perhaps, but you say I don't know. Now, let me show you something. The thing that's interesting is, if you were colorblind, colorblindness is bilingual. If you're colorblind in Spanish, you're also colorblind in English. So if you know that it's true that the cat is black, but you don't know that El gato es negro, you don't have a vision problem. What you have is a language problem. And look how this happens in math. Here's two problems. One says, at $2.54 per pound, how much does 10 pounds of ground beef cost? The second problem says, if there are 2.54 centimeters per inch, how many centimeters are there in 10 inches? I bet you every person here, as soon as I gave you this problem, knew that the answer was $25.40. You said, I'm buying 10 pounds, it's $2.54 a pound, I'll just multiply the $2.54 by 10, that means move the decimal point one place to the right, the answer is $25.40. Now I give a person the second problem. What do you think many people say when they see this problem the first time? They say, I don't know the metric system. I say, my goodness, who taught you the ground beef system? When I said that ground beef was $2.54 a pound, nobody says, hey, I don't know the ground beef system. You just took that as a given. See, what scares people is what? The word centimeters. They say, I don't know the metric system. The important point was what? If there are 2.54 centimeters in 1 inch, in 10 inches, they're going to be what? 10 times 2.54 centimeters. In other words, if you can do the first problem here correctly, but you can't do the second problem, you don't have a math problem, you have a language problem or a psychological block. Now, for those of you who've been with me in Gateways to Mathematics, you'll recognize these examples as the same ones I used there. In algebra, we're going to be dealing with a reverse version of arithmetic. See, in mathematics, we study relationships between terms. And sometimes, to abbreviate what the relationship is, we use something called a formula. For example, a typical problem in the language of algebra might say, if C is equal to 5/9, parentheses, F minus 32, solve for C when F equals 68. Now, if you're afraid of symbolism like this becomes kind of a scary problem, doesn't it? But suppose I said to you, pick a number, subtract 32, divide by 9, multiply by 5, and then say to you, what answer will you get using this recipe if you picked 68 to start with? Does anybody have any trouble saying 68, I subtract 32 gives me 36, I divide by 9 gives me 4, I multiply by 5 gives me 20? That was pretty easy. This says the same thing in the language of algebra. We're going to be talking about this as the course goes on. And by the way, even though you don't have to know this, what you really did when you carried out this recipe is you actually determined the rather important fact that when it's 68 degrees Fahrenheit, it's 20 degrees Celsius. Now, I just mentioned that to you to show you what algebra is going to be concerned with. And what I want you to see is what? Let's start gradually so you don't become confused by the language. And what that does for me is it does one very important thing now that this delivery system is going to do for you. This delivery system, in case you haven't noticed, is on videotape. What does that mean? It means if I say something in a language that you don't understand, unlike in a regular classroom, you don't have to say, oh, I got to go through all of this. When class is over, I'll come back to this. As soon as you don't understand something, stop the tape. Think about what was said. Rewind the tape. Play it again. And don't go on until you understand it. And if I haven't done my job well, and you can't understand it even if you watch it 5 times or 6 times or 7 times, go to a friend, go to a teacher, go to a tutor, and ask somebody. But the important point is there is absolutely no need for you to be moving on in this course until you've mastered whatever it is that I'm talking about. You see, many, many times, not just for language reasons, but many, many times, one of the reasons that students have difficulty in the course has nothing to do with anything other than the fact that the pace at which they're able to absorb the material is slower than the pace dictated by the lockstep of the classroom. So in this course, whether you're taking it directly with me or whether you're using this as a supplement to a course that you're already taking, there is never any need to worry about being behind. You see, if you don't understand something, you stop. And if one of your friends is watching tape number 7 and you're watching tape number 3, it doesn't matter. Because when he's through with tape number 7, he's going to watch tape number 8. And when you're through with tape number 3, you're going to watch tape number 4. You will all progress at your own rate. But the beauty will be that when you finish a chapter, you'll be ready for the next one. You won't be moving on until you understand what's happening. And for those of you who are quick and say, hey, I don't have that problem, my problem is I get bored in class, the same logic applies. If the classroom is moving too slowly for you, what can you do? Watch 2 tapes in succession. Or if you see a tape and you say, this looks easy, quite frankly, I do hope, even if that's the case, you will take the time to watch the tapes. The tapes will not take more than about 25 to 27 minutes of your time to watch. At the most, a half hour. The reason I say that is that every so often, just because you can get the answer to a problem, it doesn't mean that you got everything out of that problem that was there. One of the things that's interesting about attending a lecture, even if you understand something, is that it's possible that the lecturer will say something that you didn't need specifically to solve that problem, but that once you hear it, it expands your horizons. You see, the beauty of a self-paced system is that you move at your own pace. The drawback to it is that you usually only raise those questions that you think of. The nice thing about listening to somebody else, and the nice thing about coming to class, is haven't you ever noticed in real life, what I call real life is outside of the classroom. You're talking with a bunch of people, and somebody brings up a topic that you never thought about, but about 10 minutes later, you say, that's a wonderful topic, and a week later, you know more about that topic than the person who brought it up. Yet you never would have thought of that topic if you'd been off studying someplace by yourself. You see, the beauty of group learning is that you learn from each other and get ideas that you wouldn't have gotten otherwise. In industry, we call that brainstorming. The drawback is in a group situation is you have to be ready when the group is. And that's not fair to either the faster student or to the slower student. Okay? On the other hand, when it comes time for quizzing, you see, in the self-paced system, you will only take a quiz when you're ready to take that quiz. Okay? So that's part of the beauty of the self-paced system. By the way, some people get nervous about self-pacing. They say things like the real world isn't self-paced. Well, that doesn't matter. The fact that the real world isn't self-paced doesn't mean that you can't learn self-paced and be expected to perform at the real pace of the world later. For example, if you're learning to play a certain piece on the piano, when you first learn that piece, you're not comfortable with it. You may play it in a slower time than the composer meant it to be played. But you keep practicing until what? You can play it at regular speed the way the composer meant it. In other words, you learn for the recital self-paced, but during the recital, you do it at the regular pace. Same as in a sport. You may learn a football play by the coach having the defensive unit go off the field so you can run through the play in slow motion. Not one member of the defensive team ever says, hey, coach, I think in a real game, the other team is going to have their defense out there, and if we can't run better than this, we're going to get killed. That team knows that the coach will not put that play into the regular game book until the offensive unit can run it at full speed against real competition. So even though you learn self-paced, don't think that that's bad, because when you're through, you're going to be able to perform at regular pace. In much the same way that not everybody gets their driver's license after the same number of lessons. But if you flunked your license test 4 times, and you pass on the 5th time, nobody writes on the license, watch out for this guy, he flunked the first 4 times. Once you master it, it's yours forever. And the other thing that's nice about this is there's no such thing as staying back in this course. If I have 40 lessons for you to watch, and you only get through 25, the next time you resume this course, you don't go back to lesson 0, you start with what? Lesson 26. And the other nice thing about this course is if you've finished 36 of these lectures, you still don't get out of the course until you've done what? All the lectures. There's 40 in the course. That's the way it's going to work. In other words, you get credit for everything that you've done, and you get no credit for the things that you haven't done. And what can be fairer than that? Okay? You're going to be judged by how well you've mastered the material, not by how long it took you. It would be like me saying I taught somebody who couldn't sing as well as Marian Anderson to sing faster. What's the sense of being able to do something fast if you don't understand it? Okay? Retention is going to become very, very important in this, all right? So that's one aspect. The other aspect is, and again, I will mention this maybe from time to time, I am self-conscious when I bring it up because I don't like to tell people what I've accomplished in the past. But this is my, as we're speaking right now, I don't know when you'll be seeing this, but as we're speaking right now, I have completed 40 years of teaching experience. Not 1 year of experience 40 times, but 40 years of teaching experience. I've taught at many, many levels, at many, many prestigious levels, and also at many, many non-prestigious levels. I have developed video courses used all over the world by the MIT Center for Advanced Engineering Study. I've also produced a basic arithmetic course, some of you may have already seen it, called Gateways to Mathematics, that's used, for example, on death row in Central Prison in Raleigh, North Carolina. That's the wide range of extremes that we work through. I've had that experience. And what that means is, in a certain manner of speaking, I've been to the top of the mountain, mathematically speaking. I know what concepts are important in mathematics. I know what you're going to need later on. It means that if I can teach with relevancy, I can take the concepts that you have to know and describe them in terms that will make them easier for you to learn. See, let me give you some examples from our Gateways to Mathematics, our previous course. For example, don't a lot of students have trouble distinguishing between a million and a billion because they're both large numbers? Let me just show you a simple thing that we can do. See? A million seconds versus a billion seconds. A million seconds is, roughly speaking, 12 days. A billion seconds is 31, and this is not a misprint, 31 years. A million is to a billion as 12 days is to 31 years. This may not be a very practical result, but once you hear it, are you ever going to forget it? Are you ever going to confuse the order of magnitude difference between million and billion again? I don't think so. That's the kind of thing that we're going to be doing. Some of you may remember we did that when we talked about fractions. I've seen young children, when you ask them which is more, 2/3 or 7/15, always will pick 7/15. Why? Because the 7 is bigger than the 2, and the 15 is bigger than the 3. Now, all 2/3 means is that you're taking 2 out of every 3. In other words, if that little kid has ever shared candy with a younger brother, when he said 2 for me, 1 for you, was he taking 2/3 even if he didn't understand? You see what I'm saying? Now, what does 7/15 mean? 7/15 means you take 7 out of every 15. Well, if I take 7, that's going to leave 8. Now, how smart and how intuitive do you have to be to recognize that 7 for me, 8 for you, is a worse deal for me than 2 for me, 1 for you? You see, it's obvious just by looking here that I'm keeping more than what I'm giving away. Here, I'm keeping what? Less than I'm giving away. So if a person understands this, but gets this wrong, what is it obviously an example of? That the person didn't see the relevancy of the concept. So one of the things that we're going to be doing in this course is stressing relevancy. So you'll be watching the tapes, prepared, and I say this is painful for me to say because it's boasting, by a master teacher, by a person who understands mathematics, who cares about you as students, and wants to see you all become capable of what you're capable of attaining. You see, beyond a certain point in life, reality is what you perceive it to be. Anorexic people starve to death because they look in the mirror and what they see is someone who looks painfully fat, and so they diet to lose that weight. What goes on in nations like in Central America with all these revolutions is what's going to happen any place in the world where 2/3 of the population perceives, actually believes, that there's no hope for upward mobility. And so the greatest thing that can happen to you in the course, even including what you learn from it, is the feeling of self-esteem that says, I can do this. Doesn't matter whether it's math or not. It's to learn something, to show how the human mind can sit down and assimilate information. And why is this important? Well, for one reason, many, many times in your life, you're going to come to places where you're going to be faced with an unpleasant or maybe pleasant but still difficult task. And if every time you've come to that kind of a crossroad in your life, you have failed, what does that predict in your mind for the next time? That you're going to fail again. And I hate to use the word fail. You see, the opposite of pass isn't fail. It's that you haven't passed yet. See, the opposite of black isn't white. It's that it's not black. The opposite of ugly isn't beautiful. It's not ugly. You see, the statement that's opposite, one of them has to be true, and they can't both be true. The idea is this. If I say I mustn't fail, all I keep hearing is the word fail. If I keep saying I haven't passed yet, I haven't passed yet, I haven't passed yet, all you hear is the word pass. Attitude is a very important thing. Why is it that I can take a narrow board, put it on the floor, and walk clear across it? But if I hold it up in the air, 100 feet above the ground, I fall off. It's the same board. I'm the same person. The difference is when that board is on the ground, I'm not afraid of falling. It's when I'm in the air that I say what? I mustn't fall, I mustn't fall, I mustn't fall, and all I hear is the word fall. So what we're going to do here is you're going to learn the math in a meaningful way. You're going to find that you can do this. And what's going to happen is, in other places in your life, if every time you've come to a stumbling block, you have overcome it, you're going to say what? I've faced worse situations before, and I overcame it. And that's the atmosphere in which we're going to learn over here. I want you to watch all the tapes. Don't skip any, because there may be something in the tape that you skipped that you thought you knew. It only takes 25 minutes to watch a tape. Watch it, learn it. I can't tell you to do that. It may happen that you're watching these tapes as a supplement to a regular course. In which case, what? The label on the tape will tell you what subject it is. Simply pick up a tape and watch it if it's on a subject that you've been having trouble with. The important point is that I want you to learn as much as you can, as pleasantly as you can, and to find out that the challenge of learning can be fun. That's why we're not going over any content today. I want this first exposure into this course to be one where you see that I'm concerned about your learning. My responsibility is going to be that I will make everything as relevant from your point of view as possible. I will give you a delivery system, meaning the videotapes, that will allow you to proceed at your own pace. If a problem comes up and one day you can't learn, you're not going to fall behind. You just do what? Watch the tape when you have the time. And I'm going to try to make those tapes so user-friendly that you will feel that you have a friend in those tapes, that you will enjoy watching those tapes. And the remarkable thing will be that you will find that you can learn and enjoy at the same time. And that's basically the direction from which I'll be coming. And Ashley Montague, the famous sociologist, always defines being young as that thing about young kids who get excited about things. They're inquisitive. And somehow as we get older, we let that get knocked out of us. And Ashley Montague talks about the quest for youth. Not a magic elixir that makes you younger, but this idea of finding things exciting. The idea of finding that when you're learning, great things are happening in your mind. And he gives a very interesting commencement address where he ends each commencement address to these high school students or college students by saying, may each of you die very young, but as late in life as possible. And that to me is a beautiful saying, especially if you don't forget to put on that last part. You see, you're young as long as your mind keeps working. And you'll find that my hallmark on all of these lectures, give or take the wording, is always going to be what? Work hard, that's important, but have fun because you'll be enjoying it, and stay young because your mind will be active and you'll have the excitement of learning. So I hope that all of you will start our first lecture with enthusiasm, with hope, with a desire to learn, and I will look forward to being your tour guide on the trip that lies ahead. So until next time, what? Study hard, have fun, stay young. See you next time.